It's important for us as instructional designers to really have a grasp at a high level of what AI is and what it can do. That means we have to kind of take a look under the hood and see what drives the different AI tools that we're going to be using, whether it's a GPT, something machine learning where decisions are actually being made or classifications are being made. We want to know how that happens, and we really want to know why that happens and how we affect the outcome of the different tools that we use. We're going to take a look at intelligence in general, the role of AI in teams, because that's hugely important. It does have a role, and specialized intelligence within AI, as well as we're going to take a look at what a GPT is, generative pre-trained transformer, what algorithms are within machine learning and training. Now, we're going to take a look at all of this at a high level. You can absolutely feel free to take a deeper dive into it. I'll post some videos as well within the resources that can let you have a deeper dive into it. But for our purposes within this course, we want to know that high level, how it works, why it works, and then how we can use it in the way it was meant to be. And when I say use it, I mean use it to 100% of its capability. It's important to have a common definition of intelligence for our class purposes because there's multiple different definitions for intelligence. Howard Gardner even has multiple intelligence, and Sternberg has 3 intelligences as well that he talks about. So let's kind of define what intelligence is within the space that we're going to be working, because it doesn't relate to Gardner or Sternberg. For our purposes, it's the ability for I almost said for a person, because no, we're introducing machines now. It's the ability to be able to learn, understand, and make decisions. And I'm going to add apply what was learned in creative ways to solve complex issues. So be able to take what we learned and recall it quickly and use it in a creative way to solve complex issues. So that's really going to be our definition of intelligence as we walk through these next 4 weeks. And I completely invite you to add to that definition, change. We can even have a conversation about that, but that baseline will give us somewhere where we can all meet on and agree with what an intelligence is and how we're working forward with it through the space of machine learning and artificial intelligence. And within intelligence, we're going to take a look at specific and generalized intelligence, because just as the example that I gave in the Start Here module about the robot that plays chess that beats the chess masters, doesn't beat them all the time, I don't believe, but it has beaten the big chess masters in the world. That is a very specific intelligence. It knows how to play chess. It does not know how to play tic-tac-toe. So as people, we know how to play chess, tic-tac-toe, a whole lot of other games as well. And our intelligence is much broader than AI, than specifically the machines that do specific tasks. So that includes ChatGPT as well. Believe it or not, it's very specific on what it can do. Now that we know that AI has a specific type of intelligence, that can kind of help us figure out how AI plays a part in our team, the role it plays in our team. There's a book by Thomas Malone. He's the founding director for the MIT Center for Collective Intelligence, and it's called Superminds. Superminds are a group of individuals acting together in a way that seems intelligent. For example, companies, governments, labor markets, scientific communities, the editors of Wikipedia, which is a whole lot of people. When they act together with that common goal, they're seen as an intelligent supermind. So now think about AI in terms of superminds. Instead of saying, okay, we're going to have superminds with humans, so we're going to have this team which creates a supermind, and then we're going to have this computer which is a supermind, or network of computers which is a supermind, and we're just going to use one or the other. That doesn't really work out the best. Believe it or not, studies have been done where teams of all humans, teams of all computers do not perform as well as a team, the hybrid team where you use people and computers, artificial intelligence, I should say. So a team that's comprised of people as well as artificial intelligence being on the team, if you will, outperform computers altogether and or humans altogether. So think of the role that AI can play within your team as like a coworker, if you will. So instead of thinking of it just as a tool, it is a tool, but instead of just thinking of it as a tool, think of it as a team member on your team. And how can you use it to create that hybrid supermind that has the best of people and machine? Now we have a baseline for intelligence, what we're going to look at as intelligence within our class. We also have a baseline where we're starting to think about how AI can be a part of our team with that Super Minds from Dr. Malone from MIT. And that resource will be under the resources for week 1 as well if you want to read his book. Now we're going to jump in and go a little bit deeper into specified intelligence, that specific intelligence that AI has. And the reason why we're going to go just a little bit deeper into that is because if we're going to invite AI in to be a part of our team, we have to know the types that we're going to use. So we don't want to bring the chess master into the team because it can't tell us how to do a needs analysis. It can't create images. It can't create content. So when we're thinking about specific intelligence, think about like ChatGPT. ChatGPT just, it's mind-blowing, right? What it can do. And it's meant for duplicating human-to-human interaction. It's really good at making you think that you're talking to a person. It's very good at reaching out into its brain, which was a version of the internet, to come up with new content, so generate content. So now begin to think, do you want a GPT as a part of your team where it has the specific intelligence of being able to put together human thought, or do you want something more like a machine learning algorithm that can classify and make decisions? Do you want something that can help you in a needs analysis identify issues? Do you want something in that needs analysis that can identify or give you emotional context for the qualitative data that you're getting in? Or do you want a GPT that will help you create content? Where does that role of AI fit? And that's kind of the crux that we're going to walk into this week as well, because we have to know the purpose for the AI so we can select the right type. So we're starting to think about that already. And in our final assignment, we're really going to take a deep dive into which particular type of tool will help us the most. Now let's take a slightly deeper dive into GPTs, generative pre-trained transformers. And GPTs are a type of AI model known for their language understanding and generation capabilities. So they understand language and they generate language. And it's very human language. They do a fantastic job with it. So GPT uses what they call natural language processing, and NLP, to process the tasks so if you're using a chat bot or something like that, you're working through what we call a natural language processor, an NLP, or a large language model, LLM. From my perspective, I think of GPTs almost like a superhero when it comes to language. So I like to think about it as you have a robot buddy, you have a robot friend. So remember how we're going to have AI as part of our team. You have that robot friend as part of your team, and it is a super reader. It reads books in seconds. So it reads tons of books, tons of articles, tons of websites. And because it reads so much, it learns all these different words and how they're used in different sentences. So it can really parse each word of the sentence out and know how it's used. So I find it fascinating because my vocabulary is pretty small, but hey, that's just me, right? And then another thing that it does is it remembers patterns. So while reading, the GPT pays attention to patterns, and specifically the patterns within the words. So for example, it notices that the word once and the words upon a time often come together in stories. So once upon a time, we see that all the time. And it remembers that pattern for a later date. That's how it kind of is able to learn and hone what it's doing. So when it writes a story, so if, let's say we ask ChatGPT to write a story or answer a question, if you will, it thinks about the patterns that it's learned. So it's thinking not just about the individual words, but it's actually thinking about the patterns. And because patterns make up our language. Our language has a cadence. Our language has a pattern. So it uses its knowledge of our patterns to put words together in a way that makes sense, and it sounds nice to us as people. It uses patterns to make stories that make sense, that feel right to us. And that's how it kind of creates that human feel of it. That's the way a GPT works. And it continually gets better. How does it get better? Well, just like us, the more we read, the better we get, the more we know, the more patterns we recognize as well. So as the Chat GPT or whatever a large language model or natural language processor reads, guess what? They continue to get smarter because they're growing their base, and they always use that as training. So we're in a constant training mode. Now we know that GPTs use natural language processing and large language models primarily. There's always way more to this than what we're doing here. We just want it for what our needs are. So feel free to dive deeper into any of it that you like, and share what you learn as well, because we are all in this together. And algorithms are the next piece. Now, algorithms are really a part of machine learning. So that's identifying things. So if you want think about it. If you're on Google Photos and say you want to create an album with this facial person with this face. So in other words, might be son, daughter, brother, cousin, friend, whoever it may be. They can go through and it can identify that person in photos, whether it's side view, front view. It's pretty amazing the accuracy that it has. And it does that all because of an algorithm and its ability to classify. And how did this happen? Well, it happened with training, and we're going to get into training next because that is probably the biggest deal. But what's kind of neat is the algorithm. So you have 1,000, million, billion, however many photos of whatever it may be that you're trying to identify, identify a cat or identify a dog. And it should be able to do that with a very high amount of certainty. The way that was trained was it went under what we call supervised training first. So it had photos that were identified with cat, dog, or whatever it was being trained to do. And then it had a set of photos that it was tested on where they were not defined, and they would see if it was picked right or wrong. And guess what happened? So when it was wrong, that was an outlier. So that would receive a score of like a -1. If they get it right, it's a +1. So they further and further hone their ability to pick out the cat, the dog, whatever they're looking for. So think about that for a minute. If I am getting a negative for when I get it wrong or a positive when I get it right, what kind of training would be? It kind of sounds like Pavlov's dog, if you think about it. AI is trained in a very behaviorist sort of way, not a constructivist way where we compile our experience and such and keep moving forward. It's behavioral, how it's changed or how it's trained. And it's because, you did this right, plus you did this wrong, negative, and it adjusts. Think of it like the initial driving cars. I was lucky enough to be able to see contests that DARPA put on back in the 90s. Yeah, it was the mid-90s, I think, and it was at George Air Force Base in the high desert here in California. And the initial cars, they had a contest, and all the big companies went out there to have self-driving cars. And it was an abandoned Air Force base, and the cars would go down the road, and they would make it 20 feet before they'd go off in some crazy direction onto the sidewalk, into an abandoned house, whatever it may be. They didn't make turns. They didn't do anything. But they were just learning. They were getting that +1, -1. So, I get a +1 if I stay within the road area, this defined area. I get a -1 if I leave that boundary and end up on the sidewalk. So initially, those cars were horrible. It was funny. We used to laugh about it, how far they did not get. Now, fast forward to today, there's autonomous vehicles on the road now.